cataract surgery. So I've got to go pick her up in a few minutes.
Uh-huh.
Okay,
Yeah,
we'll let it take time.
Yeah. How's it looked like William Lee and Chloe had a really good time, huh?
Oh, we all had a great week. It was wonderful.
Yeah.
Yeah, it was rare.
Yeah. Tilo, Matt has done 2 or 3 ML 50 orientations for me.
Oh,
And everybody just loves Matt and his beautiful wife. So
They like her better.
yeah, well, you know, Cindy is easier on the eyes, right?
It certainly is. Not about it.
Yeah. So, were you able to share that video, the ML50 video, or?
I think he's already seen it.
Oh, okay.
That one. Yes, I did share that. Yes.
Okay, good.
A friend of mine that I went to high school and college with, who now has a daughter who's a physician. The daughter graduated as a physician, and her daughter and her husband are getting into sailing. And for some reason, they mentioned ML50. And of course, my friend said, well, Matt has one. And he's got a video.
yeah.
Well, look, there's no doubt that it's a great sailboat. And it actually appeals to probably a broader audience than any ML, probably in ML's history. There's a very, very broad audience because it's not too large, not too small, not too complicated. And of course, it's new and it's it has a lot of ML DNA in its blood. Well, Tilo, it's straight up your show. It's 1500 on my watch, on my phone.
Yeah, and we've got the YouTube live going, so that's happening in good shape. And so yeah, and I see that there's I see Alan is there sitting at his nav station. That's great. Yeah. And so everybody is well, yeah, and then that's also we got almost every Bill. You're odd man out. You're not sitting in your Amel.
Oh yeah, I'm sitting in my son's office, home office. You know. Okay, all right. I'm going to say goodbye to everybody. Unfortunately, I just got a text from Judy, and I got to go pick her up at the doctor's office. So I'm going to take the easy way out and view you in the recording on YouTube, which is where most of the people view these. I mean, I look at it, and there's 400 or 500 views in the YouTube thing. So good luck, and I'll see you later. Good luck to everybody.
Okay. Terrific.
Hi, Bill.
Yeah, say hi to Judy. Okay. Oh.
Hey, Tilo.
Hey. George. Yeah, Jose. How are you doing? Oh, he froze up on me. Okay, so welcome to tonight's talk, and it's going to be a bit more of a talk, and I'll tell you it is a because I'm rebuilding my forward head, and I've been fiberglassing all day, and so I didn't have a chance to do a slide deck, but so I'm going to be throwing out some terms that hopefully will just be a bit more simple, but they're all pretty much in the community of 3D printing. All we use for designators of materials are usually 3 or 4 letter acronyms, yeah, okay, good suggestion, Tom. So Yeah, also to the rest of the users, the rest of the people here, Tom's mic is not functioning, but he hears us, but he's posing questions and comments on the chat. So if you open up the chat, that will keep you in the loop of what he's saying. And in the event that I just happen to respond to his statements without acknowledging it in the chat. So so what I wanted to talk to you about tonight is materials. Last week we talked pretty much about the overview and my criteria for printer selection. And I was hoping that would give you an example of what you might want to look at. Then so that is, and it's a bit about the progression of 3D printing, because for the first 20 years of 3D printing's experience, the patent was held by Stratasys. And so Stratasys mandated the materials that could or could not be used with their printers. Basically, they generally had two. They had ABS, which I'm not going to get into chemical formula because I can't remember the damn name, but the best way to think about ABS is Lego blocks. Lego blocks are made out of ABS. ABS is a strong material, and as I think all of us at one point or another have walked across a floor that is strewn with Lego blocks in the night or something and stepped on one, and you can attest to the fact that that's hard material. And so it's a good material, tends to, or it's strong but has a certain brittleness to it, and that brittleness is highly accentuated when it gets close to when it gets exposed to ultraviolet radiation. So for anything that may be in the outdoor environment, ABS is a problematic thing. Yeah, for a few days it'll be good, for maybe a few months, but over time it will get brittle. ABS also has a big problem with the fumes that it gives off. And because when I first got into 3D printing, I had a printer. I was doing it as part of my research for my doctorate, and what I found was that was it really stunk up the office, and the person I shared with the office with didn't like that. In any case, that was the primary material used by Stratasys. They did offer something that was considered a more environmentally friendly thing, and that's polylactic acetate, PLA. And most people will use PLA for most of their designs because it's cheap. It makes them feel good about not having some horrible plastic that they have to that they have to deal with. However, PLA, and PLA especially, is susceptible to to temperature deformation. So it can be printed at a low temperature, and it isn't sensitive to being to warping, which is one of the things that you need to look at for materials, and so it's one of the most simple materials to print with. However, if you put it in an environment where it might get up to 80 or 90 degrees, so in the sun, with no wind, with any sort of heat reflection coming from anything, it will deform. And so that makes PLA not such a good material to use on a sailboat, where things that sit in the sun, and maybe are attached to a mast or something like that will definitely suffer from additional heat conduction, you're not in good shape. I mean, PLA is strong, but it's not really strong. So, and it does hold up fairly decently to UV radiation. And that makes it okay, but what we would say about PLA is it's more of a household type of material to use. I have a few rolls of PLA filament left over from 12 years ago or 13 years ago when I first started printing. PLA is also very, I had one roll of PLA that was so hydrophilic, and and where it got water into it, it got really brittle. And so I couldn't print things with that because it would end up snapping before it even got put into the printer. So that's something that you have to look at is how brittle the material is. This also gives you a reflection on how the part will behave that you print over time, and will water or humidity absorption affect the nature of that material. So those were the first two materials to come out. Then, as I mentioned last week or 2 weeks ago, we had the situation that the patent expired on Stratasys, the Stratasys method, which they called fused deposition modeling, FDM, which, by the way, our manufacturers of printers or filaments are still not able to use that term, because Stratasys did trademark that term, and trademarks live forever if the company pursues it. So, but what we saw was very interesting, because as the patent expired, so we saw that people could build their own printers even before the patent expired. From 2006, there were people sort of building their own printers. But what became more interesting was that, then when people had their own printers, they could start fooling around with material compositions that Stratasys had sort of prevented people from doing, because Stratasys insisted if you used any filament other than theirs, you would void the warranty and any service contracts you had. Now, they were selling these machines for $250,000. And so companies and groups were very reluctant to expose themselves to that kind of liability. But once people could build one for $500 or $1,000, that changed the formula. And so what we saw in the early days were a number of startups who were formulating printer filament, but they were mostly looking at blends where you could print wood, articles out of wood, which was basically just a wood, basically sawdust mixed with PLA. And so you could build with wood, you could build with stone. That gave very nice effects, but and then there were some really interesting companies that unfortunately I can't get it anymore, but a beautiful filament that I had found was not PLA. It was actually made of lignin, which is a plant-based material, and it had some beautiful, really gorgeous effects in the printing. So I wish they would still make that one, but they don't. I've searched. In any case, back in the sort of 2012 era, we did see some companies come up with early stage nylon filaments, and I have printed some things out of nylon. Nylon is extremely hydrophilic, and it will suck in water at a prodigious rate. And so, that, and I'll talk about that a bit later, because I'll go into a bit more detail about nylon processes. But those were really the only real constructive filaments to deal with. Oops, wait a minute. Hey, Matt, can you mute?
Yeah, I'm muting.
Then you can chat all you want. But anyway, the situation, and okay, Alan. Yeah. So Alan says he's made some things out of PLA, and they're okay. Yeah. So yeah, and that's the thing. He talks about 100% density. I'll talk about these things a bit more, and just to give you an idea. So anyway, I was talking about the material quality, or the progression of materials. I sort of, after I did finish my research, I didn't do much work in much research in the way of 3D printing, and I only came back to it when I bought this boat and saw, oh, there are a bunch of things that you can't get anymore, or that you need to pay a whole hell of a lot of money out for. And so this was when I got back into it, and now I've gotten back into it with a passion, because I was using my old printer that was 13 years old, and the print quality was, back in the day, it was good for a 3D printer. But then when I bought a new printer, because that one ended up burning out, I couldn't believe that even though the stated, it had, the new printer had pretty much the same parameters. You could print at intervals as low as 1/10 of a millimeter, and that was the minimal layer height that it would be able to distinguish. The quality of the printing and the quality of the control interface was tremendously better. So all of these things have improved over the last decade, and in a really amazing way. And I always knew that for functional parts, nylon was the best thing to use. Nylon is an excessively durable material. It stands up to ultraviolet pretty well, and it is, it's strong. It also has a certain amount of elasticity, so it has a lot of impact resistance. But it also is very difficult to print, and so you have to get a good idea of how to attack that and how to really print it well. And I'll talk about that a bit later. But in the meantime, now we have seen a whole new phase where the people who were originally the hobbyists who were making their own filament for people has now evolved into companies, chemical companies, really attacking this, because the demand that was coming from industry for 3D printing material to be capable of producing, functional parts was much stronger. You couldn't do a gear set out of PLA that you would depend upon. You couldn't do anything out of, you could do little things that might work for a little while, but it wasn't something that you could apply any amount of torque or power to. So what we've seen in the interim, of course, is improvement in terms of, for instance, nylon materials. But we have also seen the evolution of a, a new material that is, tremendously interesting. What I find is, of course, the pet material is very durable, very very, it's relatively easy to print. It doesn't create problems. It doesn't require, a super enclosed heat bed or printing environment. So I will, as my standard go-to material, I will go to a PET G, and PET G is, it's PET that we're familiar with, but it has gallium added to it, which gives it increased strength. And so it's a something that is more, it's dependable, it's durable, and I mean, I can buy a kilo of PET G filament for 19 euros on Amazon. So it's something that is, it's also very affordable. So for that reason, I don't even bother going to PLA anymore, because the PET G is really easy to work with. And, I've been able to, print out things. In fact, I just printed this out the other day. This is the frame that I have for my fan unit. And, so that has, a fairly good print quality. And so that's the nice thing about it. And, and it's also, it's durable. This is, something that I'm applying a lot of torque to here, and it's not going to break. There is, if I have a really thin wall like this one in here, yes, it wobbles, and if I really applied pressure, it would go. But this is a super dependable material, so that's one of my favorite ones. Then, there's also one of the other things that they've become much better at is flexible filament. There were flexible filaments in the day, but you basically just got something that was noodly and would be really difficult to print. Now, I won't kid you, flexible filaments are not easy to print. I have been fighting with printing another one of these, but I wanted to print it in white, and the only thing I have in white, this is actually has a shore hardness scale rating of 82A. There are actually 3 categories of shore hardness. There's A, C, and B. I don't know. Maybe there's a B out there somewhere. But what we usually see is A or D. Now, this is called TPU or TPE, tripolyethylene or something like that. Anyway, this is, this is an 82A. So the A rating, the A scale in shore hardness is something that's really determined to be flexible. The D rating is something that is sort of meant to be more durable. It's flexible, but it has a bit more toughness to it. And the only white that I have is a 70A, which is, very much softer than this. And of course, the boat is 28, 29 degrees, and especially in the bow compartment, which I sort of keep up. Yeah, and that's a good point. Shore A of 80 is around the hardness you have in insulation glass sealants. So, this is something that that Tom pointed out, and that's true. And the Shore 70 The 70A is generally the shore hardness that you would see in O-rings and some gasket materials. I like the Shore 70, but I'm pretty sure that the Shore, for what this is for, is this is a wiper or a gasket that's going to be sandwiched within my fan frame that is a friction seal on the outer part of the window itself, or the window frame, so that you push it in and it should then create a good friction seal to hold it in place. And so these are, but there's also 90A, 95A, and I also have a 60D, which is pretty much, I find it difficult to distinguish that from about a 95A. So it has about the same characteristics. And so these are the things that you look at. The softer, or the lower the shore hardness scale gets, the harder it is to print. And one thing to keep in mind, if you want to print flexible filament, there is definitely a better print. There's a printer qualification you need to think about. There are two types of mechanisms that feed the filament into the printer. One is called a Bowden drive, which basically is, in order to keep the print head moving fast and have little in the way of momentum that it has to overcome in changing positions, they don't want to put the drive on the print head. And so instead, they put the drive on the printer frame and then feed that through a Teflon tube and push that through a tube to the printer. Now, for hard filaments, that works just fine, because it's pushing something that is rigid, whereas here you're pushing something that is elastic. And of course, we all know how easy it is to push a rope. So this is something that gives you a certain idea. And there, when you have a half a meter of this elastic material that's being compressed because it's being forced, it's fed from the extruder print and then through this Teflon tube to the print head where it has resistance, then you can see that you've got that amount of flex and compression within it. And it's very, very difficult to print flexible materials using a Bowden drive. So, this is one constraint that you have to look at. And it's why I ruled out a lot of printers like the Enders printers, because I knew I would need to print a lot of elastic materials. And that necessitated that I would then purchase a direct drive printer where the extruder is immediately before the feed tube that goes to the head, the print head, and to the nozzle. And so that reduces the feed length from the extruder to about that much, and that's all in a more rigid format. And despite that, it's difficult to print. So I've been having endless trouble printing the 70A material just today, because the heat in the printing environment makes it even more wet noodle like, and that creates a lot of problems. And so I had a lot of prints where I'd start it and it would look fine, and then I'd walk away and not think about it for an hour and find out that it had stopped feeding, because what happens then is that the extruder keeps pushing it, but the nozzle for some reason is not taking it. And so you have to really be, the thing to know about flexible filaments, you can print wonderful things with them, but you have to be aware that it's going to require you to really change the way you think about how you want to print, because you, instead of having a very fine printer gap, nozzle gap, you have to have one that has a bit more tolerance. And so raise your nozzle, maybe increase your flow rate, so the amount that's being pushed through, so that you can keep the material flowing through. But that's a bit of a difficult thing, is to go from printing PLA or in my case printing PETG and then switching over and doing flex filament, because then I have to reset all of the settings that I have in there. And that's a bit more technical, but then I just want you to know that there are these things that you need to consider. Flex filament tends to stick very well to the printing surface. In fact, it sticks too well, and so I have to do things to encourage it not to stick so well, which interestingly enough requires using glue, because it sticks. It sticks to glue, but at least the glue will peel off of the printer base, the build plate. Whereas if it adheres directly to the build plate, then you have a lot more to deal with. So that's just some thoughts to give you on flex filament. I love it, but it's also a pain in the ass. But there are so many things that you can do with flex filament. I've also printed, for some reason I don't have one here, but the port light hold opens that are no longer made. That's the one thing that bugged me so much that I dragged my 3D printer out, was to build more of those. And I made those out of, I've done several iterations. The 83A works much better than a 90A, and 90A makes it really difficult. And what you have to do with this, you have to change your design parameters, your thicknesses, and various other things in order to, you can still get an elastic part, but you have to make it so much thinner if you're using 95A in order to get the same sort of flex that you would normally expect out of the rubber that's used for these things. And so, I would sort of guess that the rubber for the hatch, the port light hold opens, is somewhere around 70A stuff. So yeah, Christian, did you have you were talking about this, you're saying that yeah, the harder TPUs are good general purpose materials. Yeah, because they have good layer adhesion. That's absolutely true. And the tensile strength of TPU is also great. So hard TPU material, it does, as I pointed out, TPU will stick wonderfully to the print bed, and it also sticks wonderfully to itself. So the layers that are in here aren't going to come apart, and I can fold, compress this, do anything I want to it, and it's not going to turn into a stringy mess. Yeah, and that also is something that not only do here, all of the print lines are linear along the radius, and that gives the ultimate strength because you're using the continuous material, but it's holding together really well. And I am giving this really all of my strength, and it's not really going anywhere. So yeah, and so yeah, okay, A, D, and Q. Thanks, Tom. That's I knew there were three. I couldn't remember the third one. And yes, A is for elastomeric or more elastic materials. And yes, definitely, Christian, the harder materials, a 95A material is really easy to print. Still, it can be a bit temperamental. And then, then the D materials are made, they're intended to be more, I guess, durable. And they are, you'd sort of think of a D material as something that they'd make tires out of. And yeah, so it's, so that is the nice thing about TPU. It's, as far as being durable, it is not sensitive to UV. And so, this is the thing I'm thinking of, because the end blocks on my Travelers are shot, and so I'm looking at printing those out of a 95A, or maybe even something higher in the D range, to have good Traveler stops made, and just something that's easy to print, and so that would be no problem to do. And then the Traveler blocks do have a nylon insert. Then you can do that out of nylon, or really any other material that prevents you from basically torquing the bolt all the way down to compress through the material. So those are some of the things that you would think about doing. And so these are good materials to use. Now, as far as really hard materials, polycarbonate is a thing that we normally we think of as a really great hard material, and it's a really good material. It does not suffer from UV degradation. It has a lot of advantages, and it can be very helpful in doing that. It can become a bit brittle, and so it's something that has some good opportunities, especially for strengthening. So now, as an example here, I think I shared with the group that this is the ballooner car that you raise the ballooner with, and this is polycarbonate with carbon fiber blended into it. About 20% carbon fiber is in here. And of course, I also did the ballooner mouse. The ballooner car is made out of plastic anyway. It's I think that is milled out of palm, basically Delrin, and so it's milled out of that material. But this material should be easily as durable or more durable, and so that is a nice thing. It isn't quite as self-lubricating as palm will be, but nylon would be another option. Nylon just alone would be a great option to do that with, but also thinking about the ability to use reinforced nylon, and so these are all some interesting possibilities. So I'm also looking at trying to produce these out of nylon. But as far as trusting in this, I had one piece that it was slightly off dimension, and so I ended up having that around, and I've hit it with hammers between two pieces of wood, so that it had yeah, and okay, Tom was correcting himself. Sorry, it was short O and not Q. Or yeah, okay, yeah. So that's true. What you'll mostly see in filaments is going to be shore A scales. And as I say, I have one D scale that turns out to be very stiff as well. But anyway, this stuff is amazingly durable and strong. Now, and so that's polycarbonate. There are different blends that that you can also think about. There are some materials that are blended with glass fiber to give, yes, a certain amount of durability. What I've seen lately in tests that have been done is that comparing, for instance, glass fiber to carbon fiber, glass fiber doesn't give any real advantages. And so that is something that you need to keep in mind. But it does have, I mean, it doesn't seem to be much cheaper nowadays than carbon fiber blends. Kevlar is a different material. Kevlar or aramid is a different material that is given to give, it reinforces materials, but it still allows a bit more flexibility than carbon fiber. Carbon fiber has a tendency to make materials much more brittle. And so that is one thing that people have seen, that they take, they take a material that is this basically the same filament, but have a carbon fiber blend. It has almost, pretty much identical strength, but it has the advantage, then when they take a material such as ASA, it was one test that I saw, and he found that the when hit with a shear force, so a blow to the side, the carbon fiber would snap it would require less force to snap the same material with carbon fiber in it. So that's an interesting observation that I had seen. So that is, and that's the next material that I was going to talk about. I mean, polycarbonate is a great material. It's easily accessible and much, much stronger than most other things. It's also super durable. And then the next thing that I encountered is that my the self-tailing discs on the top of my Ocean 58 winches, the electric winches, are damaged. And so, this is the top disc that I made. That's the Lumar disc. And then this is what I printed yesterday. And from what I can tell, and I did this one with, this is ASA. It's unblended ASA. It is incredibly strong. And what I did in here was, it's much lighter, which isn't really a big issue, but I used about, I think I had 40% infill in this. So 60% of the thicker parts of this disc are basically have an infill pattern to them. And a lot of people think that in most parts, if you want a stronger part, you should use 100% infill, which is 100% of the interior of the print is solid material. But interestingly enough, they have because it used to be that infill was just basically a crisscross pattern of lines. But what they've just, they've done things now with honeycomb. They've also done honeycomb so that it's, instead of being on one plane, the honeycomb is a stair-step honeycomb. But then there's also gyroid, which is incredibly strong. And if you think about it, you know, when engineers are building a bridge, they get more structural strength from a box beam than they do from having a solid piece of concrete or something like that. And so this gives, now the more modern infill patterns allow you to have something that is higher strength, that has great structural integrity because of the infill. And so with only 20 or even 15% infill, you can get something that has a high strength ratio. And you know, I think I don't have any of those nearby, but I printed some things out of nylon to act as structural underlayments for the brim of my hardtop. And those things I made with one layer of the shell and 5% infill using a gyroid pattern. And those things are light as air and amazingly rigid. You know, they do bend, they do flex, but it's not something that is going to yeah. And yeah, so there are these things that are you know, that you can build parts that are much lighter and still have the similar structural integrity as you see. And now Tom pointed out that, of course, that, you know, that Eiffel was a person who was, you know, he was, you know, enamored with box beam construction. The Eiffel Tower is box beam construction, or the bridge over the River Douro in Porto is also an Eiffel construction, and that is, you know, that's really good. So then, you know, but this material is super tough. Its durability and its strength is up there with nylon, and this is ASA. And ASA is a material that they basically wanted to have something that was more friendly than ABS to print. This still gives off maybe some fumes, but I didn't notice anything really noxious or annoying about this material when I was printing it. You know, this print took about 24 hours to do, and it's not like there was a smell that I noticed. So that is, you know, and it's you know, a relatively good quality, and you know, it's something that now I do need to work on the support material, you know, because when I printed this in this manner, but then I had to have the program that did the printing preparation. It built supports to hold this up, or to basically, so that when it got to the point of printing this layer, there was some platform upon which it could print. And so it just didn't come out as nicely, and it didn't give quite the effects that I was looking for. So I still need to redesign this a bit more. But I'll have you know, I put this on my winch yesterday, fired it up, and it worked. It worked just fine. Now I do know that I need to make, for instance, I need to, you know, make this maybe a 0.5 millimeter bigger so that it doesn't bind as much onto the ring. But this cost me I think 4.5 euros for material. And yeah, so if I reprint it, I reprint it. And I'll have no problem putting this into play. Now, how long to do the design? Good question. The interesting part about it was that I had the major part of the design done in about 2 hours. And then it's the little niggly parts that took time. Now, the worst thing for me was I was trying to recreate these traction splines here. And because I didn't, you can just barely see them here, but the support pattern, they didn't come out as clearly as I want. And so I realized, I'll have to exaggerate it. But just designing the first of these little things took me forever, just because the program that I'm using for my 3D design it's really good at a base user's level, like me, because I'm not an engineer. I've never trained using CAD/CAM programs or anything like that. But I use a program that's really designed for a bit more of the novice level, and that's the program is Shaper 3D, and it works really well at something. Now, yeah, I do find that I end up having artifacts, or at a certain point, the program just says, "Oh, the edge blending on this is too complex. I can't do it." I had one annoying thing that when I tried to modify this design this morning, the program ended up deleting everything on my palette. And so I had made a copy of this because I was trying to build the entire assembly. Luckily, I made a copy of this part, which is the only part I've really designed so far. So I wasn't totally washed out, but as always, remember to copy your work, before you do anything drastic. So right now, this is turning into one of my favorite filaments, and so that is a really nice thing to work with. But generally it comes in a few colors. You can get it in something a bit more white or a bit more black or gray. So it's limited in those ways. The nice thing about PET or polycarbonate is that those are naturally transparent materials. So now printing transparent, you have to think more translucent or semi-transparent with 3D printers, because you remember you're layering on things. Now you can do some post-processing to try and bring a bit more clarity to it, but you're not going to be able to print windows, for instance, out using a 3D printer. I am considering trying to print out of polycarbonate a better drip shield for the galley and the bathroom port lights, because the galley technically has a drip shield, but if you leave it open in a rainstorm, it's still going to have water coming into it, and the bathroom is horrendous. So I'm thinking that doing a window, an insect screen with an overhanging translucent or semi-transparent cowling would be a good thing to try and prevent everything except the worst rain from that's blowing sideways from coming into the window. So that's some of the things that you end up dealing with. So these are the materials that I've been discovering really over the last 3 or 4 weeks, month, something like that. I can say that I'm really impressed with polycarbonate. That's good. Not polycarbonate, ASA. This is a wonderful material. Yeah, and so, Matt said that he did a nav light lens 3D, about 15 years ago. Had to do some sanding and polishing, and this is one way to do it. There's also acetone smoothing, and this is, you can't. Acetone is a solvent to most of these plastics. That means you can't just wipe acetone on there because it will just destroy the object. What you do is you put the part in a heated environment that has acetone in there that generates acetone vapor, and then you let that low density of vapor just soften the very outer layer, and then you can go over the outer layer to smooth it. And so there are many of these possibilities, and these are things that I do know about. I haven't really bothered doing that because final finish to me, I'm more of a function person, so final finish isn't that important. But you can get some transparency, but don't expect to have optical transparency on this. One person asked me about is it possible to do the rudder indicator on a Sharky? And it appears, I still need to go over to my neighbor who has a Sharky and take a look at that. But it appears that is a transparent covering of the rudder position indicator. If I can do it, I do have transparent polycarbonate. I haven't printed anything with it yet, so could be my next project. Now, some of the printing materials do not adhere as well to the build surface. And so what I'm going to do briefly here is talk about build surfaces. And that is, you have, traditionally there's glass, which is a great build surface, but it doesn't, it gives you just a very smooth surface to print on. Some things stick wonderfully to glass, others don't stick well, and so you need to use glue, which the glue, if you use glue stick or Elmer's glue, that is I think that's PVA, it's PVA, and some glues are PLA. And so these are some of the things to think about. You're basically setting an adhesive down on the bed and knowing that the material will stick to the adhesive, adhesive will stick to the bed. But even for some materials, that's not good enough. Now, printing this, so printing polycarbonate, I had a lot of problems with initial prints not sticking to the bed so well. And that's including the fact that I used glue on the bed. By the way, I got sidetracked. The other option for beds are PEI sheets. And the advantage to the PEI is that many of these sheets, they mount to your print bed, your print platform, with a magnetic sheet underlay. And so it's very easy to remove the sheet. And of course, with rigid parts, then if you remove the sheet and just bend it a bit, you flex it, then the parts will pop off. And PEI sheets generally come with two flavors, either perfectly smooth, which is good. For instance, I also printed the flapper valve for the bilge pump out of a flex filament, and that needs to have a super smooth surface. So I used the PEI sheet, the smooth surface side, and it is, to a reflective finish. But what I really like about the PEI is that it also has a textured sheet, which I don't know if you can see that, but it has a beautiful texture to it that if you look at this, you just don't really think that that's a 3D printed object. And so I find the PEI sheets to be really, really good. I've heard that there are also the same type of sheets, but they're made with a nylon coating specifically for printing nylon. But what I've found to be, even despite using the glue, things don't stick on. And also with this, it has trouble sticking. And a lot of the things that you have to think about are, so ABS and ASA and nylon, and to some extent polycarbonate, but not quite so much, have a tendency to warp. And so they warp because if you have things that are getting cool on the bottom after being heated up, they tend to contract. And then, but when you're laying on new layers, they tend to expand, and the differential expansion contraction that causes warping. The newer slicer models, a slicer is a program that takes a 3D model and slices it into the layers and generates the code necessary to 3D print it. They also allow you now to put a brim on the part, so that if I have this part that I'm printing, I can tell it, okay, I want an 8mm brim all the way around it. And what that does is that increases, it effectively doubles the adhesion value that you have, the surface area that's contacting the print bed. And it works, it works wonders. Now, of course, the other thing you want to do is keep things nice and toasty for these materials. This material, it didn't need a super hot nozzle. I printed this with the nozzle temperature at 245, but it wanted 100 degrees on the platform to keep that really toasting away. Now, I also I have both of my printers working in the forward compartment, have the hatch closed there and the door closed, and that compartment was a sauna the other day. And with one bed at 60 degrees and the other one at 100 degrees, these are big heating elements. So keep this in mind. You have to be aware of how you need to keep your printer environment when you are printing. And these are the types of things you need to be considering. So that's basically what I wanted to talk about tonight, and I'm happy to answer questions for you as well. The next session, what I want to do is I will start talking a bit more about the technical aspects of design and how to print things that other people design. And most importantly, I'll talk about slicer software, because that is the intermediate step that every person needs to learn, and that can be a bit cumbersome to figure out. So I'll be next time talking a bit more about the steps that you need to do now. I've talked about printers, I've talked about materials, and I'll try and bring it all together with actually talking about then how you get a design to the printer and print it out. So that will be my plan for the next session, which 2 weeks from now I can't do. So probably be 3 weeks or so, sometime late July. Yeah, because yeah. So okay, so Jose, yeah, glad to hear that. It's really a fun thing to do. It is aggravating, but as I said, one thing that I am prepared to do is a lot of the designs that I have made, I will be setting up a folder on the group for having, in the groups IO thing, where we'll have a library of not only the STL files, which are sort of the output files that describe the shape, but some things I'll be willing to share the shape files. And now that's a proprietary software. You'd have to use Shaper 3D, but from my experience, yes, I know the limitations of Shaper 3D. It is at a certain point I get to screaming at it and saying, "You dumb program." What do they say? Yeah, there's no such thing as dumb programs, just dumb programmers and dumb users. And so these are the considerations that you have to have in there. But from my perspective of somebody who is not, I had tried messing around with CAD/CAM programs before, and they are so cumbersome to deal with if you don't really use that as a work basis or something that you're trained on professionally. I mean, my wife is a landscape architect, and she uses 3D design programs for her work, and so she can do things really quickly. And I look at her and just say, "Wow, you're a magician." But the Shaper 3D program has come out to be, for me, it's a real godsend. And I get to the point, she was asking me about that earlier this evening. Oh, are you going to learn that? And I said, no, what I'll probably do is I'll take my Shaper 3D program and send it to somebody who is a professional draftsperson in CAD/CAM and say, if I want to use something, to sell it professionally and want to have a proper clean production file, then I'll send it to a person. They have everything dimensionally, and just say, can you please now just reconstruct this in a proper three-dimensional CAD/CAM format, and they can probably do that in an hour, 2 hours, something like that, because it's not that complex. As I said, the major part of this design took me an hour and a half, 2 hours to do, because it's just basically saying, okay, I have 1, 2, 3, 4, 5, 6 concentric circles. Define those by their diameter, have them, and just, you just take one to say, okay, make this one, 4 millimeters smaller radius, and bam. Once you learn some of the tricks, it's easy. And then, so all of that big stuff was easy to do. And then it was just the small niggly detail stuff. I did do these little notches, which are technically not necessary. They're not functional, but they are good to be able for someone to see whether the winch is spinning or not. So it's a good visual indicator. those took me about an hour and a half or so to do, just because it was somewhat repetitive and I had a few glitches in there. And then, and as I said, this took me about a day's worth of aggravation, and I probably have to start over on that, because it won't let me modify them easily. And at a certain point, the nice thing about Shaper 3D is that they do have a huge library of instructional videos, because another project that is eventually on my list is to try to design the entire internal gears of the bow thruster, because of course half of it is plastic already, and this is a fiberglass reinforced plastic material, and that's joined this way. So what if I use something like carbon fiber reinforced nylon and construct this, and just do a bevel gear and the mating gear also? So that is, one thing you have to be concerned about is that carbon fiber is fairly abrasive, and so in a dry environment that would be worrisome, but in a lubricated environment that has no real concern. It'll polish out. So it'll be an interesting test. I do have the bung for dropping the bow thruster in the water, so it would be it would be something I wouldn't have to worry about too much if I grind it up. But but it's worth a try. Anyway, these are all the things that you can think about. And what I've seen now in the last, in getting into looking at materials, is that the plastics that are out there have a tremendous durability and strength, something that before we wouldn't really think about as being possible. But I'm really, really impressed with what I've seen in the new materials and everything I'm learning every day on these things. So there are some things that probably I can't do, but I am certain, for instance, that the end fittings for the ballooner poles on the Super Maramus and those, which I know two people who had to have those replaced, and I think they said it was $5,000 or something to repair them. And it shouldn't be so. I'm pretty sure that with a carbon fiber reinforced material, or just a plain ASA material, we should be able to do that. And this gets to a point where, okay, you're out in the South Pacific at a remote island, and something breaks. Instead of thinking, oh crap, we're done in, say, oh well, I can mod that up and print it. Or wow, it just so happens we've got a whole library of these things, and that's there. It's possible now. It's not just something that you think, oh yeah, but you can't trust the strength of those parts. All of the information on all of these filaments are out there, and if you learn to get a sense of not only thinking about the structural capacity of the materials, but also of the way to design and print things so that the vectors of force are in line with the strongest fiber strength that you're laying down. And so, that's why on this, for instance, on the actual print, I made sure that all of the external lines were made in a were done on a circumference basis. So instead of having it print things in a crisscross, now the internal infill structure is done in a cross box fashion, specifically so then that can handle more torsional forces and things like that. And it's not rocket science, it's not difficult. You can do this because the patterns are already designed, they're in the slicers. And so it's not like you have to then think about how to design it. You can just know, oh yeah, I mean, honeycomb pattern, especially the three-dimensional honeycomb pattern. I mean, that is one of the strongest there is. Gyroid is super strong. All of these things are possible, and you really don't have to. You don't have to use, have this specific knowledge. So these are the things that you can consider, and I have more confidence now that when we do start our cruising adventure, we don't have to worry about it. And specifically the Lumar winch, the thing that is the worst problem is the actual stripper ring that goes inside of here. It's plastic, and I took this one apart. Now this piece is in fairly good shape. On my other winch, this piece is chewed up on one point. It got eaten up by a rope or something. But and they want 187 euros for the entire kit, which is criminal. And so you can do this, you can make it. And this, I'll probably just donate this design to the library, just because I don't think I want to take the liability of doing that, but it's just something that's fun to think about. But yeah, there are a lot of good and interesting opportunities of things to do. And the nice thing about, I think about 80% of the stuff that I'm printing, you can do on a relatively small printer. And it's funny. Both of my printers are made by the same company. The really big printer that I use to print this, which has it's a 40 by 40 centimeter bed size. That's a printer that has more difficulties. The smaller one that has a 23 by 23 bed size that I can print this on and most other things, that one just works like it's a soldier. It works great, and it's easy to break down. It can be stowed with relatively little space. So, I mean, I really enjoy that. And, so these are the things to think about, but you can do it. And I'm, as I say, somebody was asking me, wow, are you an engineer? I call myself a field engineer, but all of my degrees up to PhD are in management and economics. And so it's not like I'm a born and bred engineer. It's not that hard to do. It will be a lot of hair pulling and figuring out the tricks on that. And what I'd also be willing to do is just either have a workshop where people who have their printers, get online and we talk about printer specific issues. But truthfully, most printers, the technology in them is more or less the same. And so what one person is talking about, what nozzle do I have to use for this or that or the other, things like that. Those are simple things. Yeah. Anyway, do any of you have questions? Oh, yeah. Okay. Jose, yeah, you'd be having a rotator cuff surgery. Yeah. So this is good. Yeah, I think then we'll definitely, as I say, what I recommended because in the last session, if you watch the first session of this on YouTube, you'll see I personally chose the printers designed by Mingda specifically because they're gantry printers, which have a gantry frame to them. You can set them up and take them down in 5 minutes. And so that makes it really easy to, for a sailor, whereas people talk about they had Ender series printers or other things. They said you have to take every panel off just in order to detach the gantry because they have everything buried in different ways. Mingda is the only one that really thought more about flat packing and making it easy in that way, which is nice because on Monday I'll be driving up to Zurich for a couple of weeks and wanting to keep some of my production going, and so I am going to, for like the 10th or 15th time, break the printer down, box it up, and then put it in the car and head to Zurich. I mean, the most difficult part about that is getting the thing down the ladder off the stern because I'm up on the hard. But anyway, these are all the things to do. So look at the Mingda printers. I think right now they constantly have sales going on. If you buy it directly from Mingda, it tends to be a bit easier. They have, they don't have jacked up prices on their website, which, I ended up buying my big printer from a 3D, online shop, and ended up finding out I didn't get a great deal there. And on top of that, it's been a bitch of a printer to deal with. And right now I've got that one boxed up and waiting and arguing with the company for getting a replacement because I've replaced all the main components and it still doesn't work. But then I knew that I would need to have extra printer capacity. So I bought a second one of those, unboxed the second one, started printing right away. And so these are the things to think about, is that I don't begrudge a company that I got one printer that somewhere in it, it's either, maybe there's something wrong with the power supply, maybe there's something wrong with a wire connection or a ribbon cable, but stuff goes wrong, but it works. So, these are the things that, that I'll be looking at, and Christian, I will be looking at, I will be going over tomorrow and bothering my neighbor and looking at the Sharpie, what he has there, and seeing about, can I do something that is functional enough for a rudder indicator knob, because those clearly have disintegrated over the 30 years or so since those boats were built. So anyway, these are the things to think about.
Yeah.
Any questions from you? Yeah.
I was asking you if you could give us a list of materials to start playing with. I don't think we're going to start making anything really serious, but at least to start playing with and familiarizing with the different ones that are available in different types of things. The semi-transparent one, I thought would be nice to do it for the fans on the that you're making them large. I made them in just a piece of plexiglass, and I cut them out, and that's where I put my fans. And the difference between that and the wood one that I made before, in terms of light coming in, made a huge difference. So it doesn't have to be transparent, but any semi-transparent thing that allows the light to come through, it's make it a big difference.
That is the nice thing about the white fan frame, because I did use a lot of infill in that, and so you can see it some light during the day, and that does help. But of course, I have a channel in there that contains all the wiring, and you know, there are a couple of circuit boards that I have inside there. So, you know, these are things to think about. And but certainly having things translucent in that situation, and you know, as I say, for a starting material, sure, you know, I like PETG, and so if you can get it in transparent, and so that's the you know, it's a friendly, inexpensive material to fool around with, and it's actually strong enough to make functional parts with. So whereas most people, I mean, yes, we saw that some people are using PLA for functional parts, and but now, I mean, by and large, when I see what people are printing out of PLA, it's, you know, they're printing superhero models or models of the Starship Enterprise or whatever they want to, or printing chest plates for their superhero cosplay cartoon character or whatever. But my basic opinion is that for printing functional parts, you should just start with PLA and then go up from there, because it's a good material, and I've really enjoyed working with it. So, and it's hard, it's durable, and you know, I even I had lost a hinge for one of the doors in the galley, because I had to take the galley apart at one point, and in desperation, I found it since then, good thing. But in desperation, what I did was in 20 minutes or so, I mocked up the hinge base for that. It was only the base that attaches and screws in, printed out of PLA. It's black PLA. I didn't have any silver or anything like that. And then just found one of the most out of the way cabinets in the forward compartment that you just can't see at all, and changed that out, took the proper hinge and put it in the galley, and you know, so as a temporary fix, it's a great thing. And I still haven't gotten around to changing that back, but yeah.
I don't know what the material was for the ballooner piece that I sent you the drawings. I made that. I had it made. I had printed it from a shop. It was professional printed, but it's still there. I mean, it works like it should. There was a little error in the design that I had to file, as you noticed too, but it worked very well, and it's still in the boat.
Yeah, and is it a whitish material?
Yeah,
it's nylon,
it's probably nylon.
It'll be there going onwards, and nylon is probably the best material to use in that case, because it's self-lubricating, and you know, whereas, okay, I did this out of polycarbonate more to test it, but I think I'll ultimately print this out of nylon. Whether it needs to be reinforced, you know, that's questionable, and whether I decide to actually press in, I don't know if you pressed in something in here, or just have. Yeah.
No.
So I mean, that's just okay. Do I press an eye into it? But I think a brass eye and just use a flaring tool to that and should be easy to do.
Yeah, when I bought the boat, they were showing me the ballooner came out of the box, and I stood up exactly on that piece and cracked at that point. So I didn't have the tip. When I had the design of it in 3D, I didn't have the tip, so I had to kind of invent it, and it didn't come out exactly right. But
yeah, so I mean, and this, then I took your design, and then I actually took my iPad out to the bow and pulled out the ballooner car and compared it and said, oh, okay, now I see it needs to be this and this and this, and that was easy at that point. And but yes, this channel here was perfectly done, and so that is unaltered, other than the fact that I didn't even do enough of a rounding on that, but but that's great. So thank you. Anybody else have any questions? No? Well, it's been really great. I hope you've gotten a good deal of information out of this. If it comes to your mind that you think there are other issues that you would like clarification on, feel free to let me know, and I'll integrate that into the third part. So, I think that should be pretty fun.
Just one thing, Tilo, that I thought, since you've given us so much information on all this, and we're going to start buying these printers, at least I am going to offer to buy one. Is there a way we can mention your name, and so that you can get some sort of a kickback of what, I mean, they're selling the stuff because of you, so it wouldn't be more than normal that they would, give something, at least to send you some materials or parts or whatever.
I'd love it if they just send me a replacement printer, but I mean, I understand it, and I've told the company, I said, yes, despite having this problem with the large printer, I've had nothing but good relations with the smallest one that they make, which is the Magician X. And it's wonderfully functional, prints most everything, unless you're trying to print, screen frames for the port lights and the windows, then you don't need the Pro, which is the big one. And I just, out of practicality's sake, I wouldn't think of doing that one. By and large, the vast majority of things that you would need to do on the boat, and I think that includes the ballooner end pieces, you can do on this smallest printer, because it has it's 23 by 23 by 26. And so it's a relatively big build volume. And
just one question on some 3D printing parts that I had. I'm trying to find one here, built from me here at the Mass General. This is a little bit more of a complex part, but I'm just going to ask you if you see, when they did this, okay, this part, I remember they had to put some filling material. There were two materials being printed, one that was just simply to hold the part, and another one that was doing the strength. And then I had to take that and clean it and flush. How do you handle those?
I use the same material. because I mean, yes, it's true that you can get a dual extruder printer. And in fact, that's the first one that I had was a dual extruder printer. I ended up giving up on that because trying to coordinate two extruders to print exactly at the same level, the same position is super, super difficult. And so that's the thing that I would say is it just makes it hard. And I've had no problem or relatively little problems with just basically having the support structure being built out of the same material.
I see. So you could, in the case of this part here, you could have some extensions here, and then you just simply get off of them. You can get them off.
So,
okay.
For instance, on this, I have the tabs that the fans screw into here.
Okay.
And I print it this way because if I print it this way, yes, the tabs would be secure, but then I wouldn't have as nice of a finish as I do having it down. But then I would also have to have all of this void space supported. So printing it this way,
right.
The printer just out of PLA material builds support structures underneath here. And so that then is supported. And it's true that I haven't dialed in exactly how much of a gap I need to have between the support structure, because it does break away easily. But
so it's not
then
it's just simply printed a layer, but how does that layer doesn't fall off, or do you have something that attaches it to the rest of the part?
Well, it attaches to the build platform. So, I mean, if I were to go and grab out of my printer trash, I do have the support structures, and they just snap off, break away.
Snap off, and then you sort of
and then I
did a knife or something.
I went over it with a knife, and so, I mean, and then if you look at it, I don't know if I'm holding that. Wait. I don't know if you can see that so clearly, but it's got a very rough face here.
Right.
And that's I have seen times where my printer interface has been very, really good, and it had the spacing just right, and things snapped off, and it was a really clean surface.
Tilo, do you have to design the support structure, or does the software do that?
No, the software does it. And there's two types that you can use. There's either standard, which is basically like it's building a gantry or a scaffolding underneath here. And then there's also a method that's called a tree structure. Now, the way the software that I've been using lately does it is that it uses about twice as much material for the tree. And so it's more of a root structure. I need to figure out what settings, either that or I need to go back to the slicer that I've used before, which is a bit more user-friendly. And there it uses a single or a very narrow base and then builds up from there. Now, of course, the difficulty is making sure that your base material adheres. And, that is a different thing to worry about. But that's where I also think brim structures have come to a really, really good point where they work well, and they allow you to have a superior adhesion and again, and the brim just peels off, because it's just attached by with a little teeny gap, so that it's not printed directly onto it, but the material it touches well enough so that it's holding together, but then just a little bit of shear force and it comes away. So these are the things that you can think about. And the advantage, it used to be, I think, a bit more important to have a separate support material, because the filament was so expensive. But at 20 euros a kilo for the cheap stuff, and then or even this is 36 for this stuff, for a kilo, it still is much cheaper than it used to be. 10 years ago we were talking about like 50, 30 euros a kilo for the cheap stuff, for the PLA, and 50 for some of the higher end filaments. So prices are coming down too.
Good.
Great. Well, I have really enjoyed it, everybody, and hope to see you anticipating in 3 weeks. And as I say, if you have any burning questions, you can always contact me directly, or if you want, if there's things that you think are more of a sort of a group answer, something that's good for everybody, then let me know, and I will make sure to put that in my next session. Okay.
Thanks, Tilo.
Okay.
Thank you very
Thank
much,
you all.
Tilo.
Have a great night.
Bye-bye.
Bye bye.